Asked for an amortization example, so I'm going to give you a quick example, and I'm going to make the numbers up off the top of my head. So the typical amortization example is that I have a house that I want to buy or a car that I want to pay for or something like that, and usually you have some loan amount, and this is also going to be your PV, so I'm going to put PV in parentheses. Oops, of course that messed up. Loan amount PV. Okay, you're going to have some stated interest rate. Let's say that we want to buy a car because it's a little bit easier. We're going to take out a loan of $30,000. We're going to have a stated annual interest rate of 5%. We are going to do it for, let's say, 5 years, and that should be all we need. So the problem is we're going to make monthly payments. So this is not the correct rate. This is 0.004 is the effective monthly rate. And I'm going to write this up. Let's see, what's the best way? I'm going to insert a column. Actually, let's do it this way. And let me just wrap those cells. Okay, so we have our stated interest rate, which is 5%, but it's compounded monthly. This will be given to you in the problem. Most of the time, occasionally, you might have to infer, but usually it'll say the auto loan rate is such and such. You have monthly payments. It's compounded monthly, and it will give you an annual rate. And you will know that you have to divide by it because of that weird legal thing where, I don't know why they do that, but they never give you the real monthly rate. They give you the annual. You have to divide by 12. Okay, so this is the real monthly rate, which means that we have enough to start the problem, except for the fact that our years are in, we're in monthly rate here. So let me just, now that we have the monthly rate, let's get rid of these. And now that we have the years, let's figure out what time, the actual number of time periods is going to be 5 times 12. We have 60 time periods, and I'm going to make the year go away as well. Okay, so the next step, we have our loan amount, we have the number of times, and we have the real monthly rate. The last step is to figure out what the payment is. We can do this using the annuity formula, the C over R times 1 minus 1 over 1 plus R to the T, or we can just use the payment function on Excel, equals PMT parentheses, our rate is 4%, our number of periods is 60, the present value is 30, and the rest of those we don't have to worry about. We hit enter. Remember, it's going to give you that negative number. It does that because it's a weird Excel thing, so I'm just going to put a negative in front to not confuse us. Okay. The easiest way to do these problems in Excel is to do the beginning balance. I'm going to wrap the text, the time period, the interest expense, and the payment, and then the ending balance. They're going to be all weird. Let's see if I can wrap the text on all of them. And I personally like it centered because I'm weird. Well, let's start it this way. Okay, you can do this a lot of different ways. At time 0, you're going to have a loan amount of $30,000, and your beginning balance at time 1 will be the ending balance from the last period. So that formula will work. The question is, how much do we owe in interest? Well, that's going to be your beginning balance times your monthly real interest rate. Your payment is that. So let me add a column here just to make it super clear. Okay, so we have our beginning balance of our loan. The bank charges us this % interest every month. We owe now, after they pay that, $30,125. But we make a payment, and so our balance goes down to $29,559. When we do that, the same thing happens the next period. So let me make sure that I lock the cells. This C10 references, we're going to change that every time. H3 is the real monthly rate, so that's fine. We're going to hit enter. What we owe is fine. Our payment, let's lock that. And our ending balance is just relative. Okay, so all of these equations are fine. I'm going to paste that all the way down. I'm going to make the loan period a little shorter so we don't have to do as much of this. Let's do, instead of 5 years, let's do a 3-year loan. So only 36 periods. Here, let me make this black. So I changed 5 years to 3 years just to make it a little easier for us to see. We are at 30 time periods now. We only need to drag it down to 36. But I'm going to leave this up. Okay, so in the first month, when we make our first payment, our interest expense is $125. We owe $30,000, our interest plus our beginning balance. We made a payment, and our ending balance is what we owe minus the payment. Each month, we are going to have a different amount of interest expense because our payment is just large enough that the balance declines the next month. And what's cool about the annuity equation, this payment of $899 that we did using the payment example, when you get to month 36, notice that the balance here, I'm going to make it yellow, notice that the balance here is 0. The balance being 0 means that we're done paying the note. We did it in month 36, which is exactly what we have up here for the length of the annuity. If we were to keep paying, they would actually owe us $899 at the end of the period, but of course we don't. They give us the title to the car, and that's the end of the amortization. So if you want to build this, you can do it rather quickly in class and on the test, and this is how I would solve this. So, you know, the question may be, in month 12, how much interest do you pay on the balance of the car? And the answer is $89. And it's just as easy to set this up as it is anything else. So again, what we did was, let me highlight everything and make it black again. We had a loan amount, we had a number of years, we had a stated annual interest rate of 5%. We did a couple things. We calculated the real monthly rate because the problem told us it was compounded monthly. We changed the time period from 3 years to 36 months because the number of months has to equal the number of time periods that are implied by the interest rate. We calculated the payment, which all we did was equals payment, and plugged in the numbers according to what Excel asked us to plug in. And then we made a couple columns: time period, beginning balance, interest expense. We added this. You don't really have to, but we said, what do we owe? Well, we owe the beginning balance plus the interest expense. We made a payment, so the ending balance is what we owe minus the payment. And that's the way that I would solve an amortization problem. The way you can check yourself is if you have the number of periods, if you copy it down all the way, and you get to 0 at the time when the final period is, then you've done it correctly.